ready for takeoff.
Hi, everyone. I hope everyone's had a good start to RubyConf 2022. I'm Dylan. I'm incredibly excited to be here. This is my first RubyConf and my first conference talk. So I'm excited, a little bit nervous, but I hope you all enjoy the talk and can take something away from it. I'm a software engineering manager from Cape Town, South Africa, where I studied mechanical engineering, actually. But about 5 years ago, I dropped out of a PhD and somehow landed a junior dev job at a company called Zappy. Zappy is the world leader in automated end-to-end market research, with offices in Cape Town, Boston, and London, and some satellite people all over the world. Our stack is mainly Rails backends with React frontend, obviously, a little bit of Python, and Elixir thrown in for luck. We've got millions of lines of Ruby across a number of different apps, and we've also got all the tech debt and spaghetti that comes along with that. And so about 2 years ago, we started to notice some problems with our engineering department. Delivery speed was decreasing, engineering happiness was at an all-time low, and our innovation was just stagnating. So it really felt like we'd forgotten how to disrupt, and we were plodding through the muck of BAU and customer requests and bugs that were happening more and more often because we never knew when we would break something. So it obviously needs to change. The problems we were facing weren't unique to us. High degrees of coupling, poor software practices, frustrating process, these are all things that most companies at a certain scale have had to deal with. So then surely there's something out there that can teach us how to move forward. Let's go. Just going to do that. So enter the State of DevOps report and the DORA metrics. For those who might not know, the State of DevOps report is an annual report on software engineering, and it strives to understand what makes a high-performing team. Now, the researchers take a rigorous scientific approach to gathering and understanding that data, and all of that is described really well in the fantastic book, Accelerate. Now, the outcome of years of research was these DORA metrics, which together are indicators of high-performing software teams. Deployment frequency is a measure of how often an application can be deployed to production. Change lead time is the amount of time between writing some code and getting that code into production. Change failure rate is the rate at which failures happen. And then mean recovery time is the amount of time it takes to fix any failures. There has been a new metric added, reliability, but there's still a bit of debate around its validity. So I'm not going to touch on that too much. But it's important to notice that these are metrics and not goals. Anytime a metric becomes a goal, it can be gamed. So we don't want to look at how we can game these and improve them just by doing anything. Instead, you focus on the best practices and the behaviors that have been proven to improve the metrics. As a tech lead about 2 years ago and an EM now, there's one particular behavior that I'm very, very passionate about, and that's obviously trunk-based development. It's an alternative branching strategy which encourages more regular but smaller commits to master, and it directly leads to significant improvements in your deployment frequency metric. It's been proven that organizations that practice TBD are more performant. But if that's the case, then why isn't everyone doing it? Why aren't we all doing TBD? That's what I'm here to try and answer. So let's explore TBD and why it's so difficult to adopt at scale. Now, TBD purists have very specific definitions of trunk-based development. If you're doing it right, then you should be committing and pushing straight to master, and you should be pairing whenever you're writing code. The thing is, when I hear this, I like to remember one of my favorite Twitter posts by G. Paul Hill, which is, I don't like or value definition wrangling, and I don't care whether you call how I work TDD or not. Probing the boundaries of ideas is great, but axiomatizing natural language is boring and often a form of browbeating. So he's obviously speaking about test-driven development here, but I think the same can be said about trunk-based development. What's important is the intent and the result. If we aren't sticking to the letter of the law, but we're still gaining the same benefits, then it really doesn't matter whether someone on the internet fights you about the definition. But that does mean that we have to figure out the intent and the benefits of TBD. So the intent behind TBD is to keep each of our commits smaller and commit more regularly to the trunk. It avoids feature and integration branches entirely by understanding that the only true integration branch is master. So compare GitHub or Gitflow branching strategy. They have their differences, but a common pattern to both of them is that you have moderately long-lived feature or integration branches of some sort, and one or more people are committing to those. They're generally deployed to a non-production environment where they are QA'd or fiddled around with, and then at some stage when the feature's done, it's merged into master and deployed to production. Now, the problem with that approach is that the longer lived your branch is, the more it diverges from the truth. You may branch off from a feature branch to do some kind of patch after QA, and then merge back into the feature branch, and then you merge that back into trunk. And by the time you do merge it into master, master looks nothing at all like it did when you first branched off. So upon some inspection, these strategies are filled with problems. The probability of merge conflicts is high if you have multiple teams working in the same code base. The probability of bugs is high because what you test is not what trunk actually looks like. And you also tested probably in a non-production environment, so the data and usage is different. The probability of big PRs is pretty high. We all know the meme, 1,000 lines diff, 1 comment, LGTM, thumbs up, 20 lines diff, 20 comments. It's funny because it's true, but what does that say about the quality of the reviews on these big PRs? And what does it say about the team's understanding of the code that's going into their repository? Personally, if it takes me more than 5 minutes to understand every single line of a pull request, I'm not going to review it. I'm not going to approve it. I'm going to go to the developer and say, hey, can you break this down for me and really help me understand your code? So how do we fix all this? It's actually quite simple. You just don't use long-running branches. Treat the trunk as your integration and your testing branch, and keep your commits small and precise. That way, the chance of merge conflicts and divergence is massively decreased because your branches never really live for much longer than a day or two. Now, because you're committing so frequently and in smaller chunks, your PRs and commits in general look quite different from other branching strategies. You don't really commit full-fledged features in one go. Instead, the unit of value is a lot smaller. If you finish writing a class and it's spec, then you ship that. It doesn't really matter whether it's been through QA or tested, because if a class, method, or function, or any piece of code has an associated spec, and it's a good spec, there's no reason for it not to exist in master. Now, there's 2 rules of thumb I like to use for determining whether my commits or pull requests are too complex. The first is number of files changed. It should always be 2, a functional change and a test. And then the second rule of thumb I use is about the description or your commit message. If that includes the word and, you're probably doing a bit too much. So now that we know what TBD is and a bit of what it looks like in practice, let's talk about the benefits. So first is that you deliver value much faster, but in smaller increments. Every good commit should deliver some value, even if it's just making future development a tiny bit easier. You get better feedback faster because your commits are smaller and more focused, so people actually discuss the functionality instead of whether you're using single or double quotes or have a space after your brace. So now this, along with more emphasis on pairing, creates a better sense of collective ownership within the team. TBD provides you with a more accurate commit history. as well as simpler merges. Now, a merge conflict is an inherent indication that your work is out of date. If you need to resolve a merge conflict at time of merge, then you really should go through the entire QA process again, because what you're shipping is not what was tested. And then speaking of QA, it becomes simpler, more reliable, and has a higher quality. We've all joked about testing in prod at some point, but when I say it now, it's not a joke. I don't see value in testing in a non-production environment, because it's always going to be a poor imitation of reality. And last but not least, TBD makes you feel like elite hacker straight out of a 90s film, because there's just something thrilling about committing 10 to 15 times a day and shipping those all. So now all of these points, except possibly the last, are not my opinion. They're facts, they are proven. The state of DevOps has proven that organizations that practice TBD show higher performance than those that don't. So again, the question is, why isn't everyone doing this? In trying to push for adoption at Zappy, I've desperately tried to answer this question. And what I've heard are a lot of excuses. They all seem to fall into one of three categories. First common one is that it's not applicable to my work. Oh, I'm doing a big refactor that has to go in as one thing. Or my work crosses multiple apps that all have to be updated together. Or I won't know it actually works until everything's running together. There's only one case when TBD is not applicable, and that is open source. Because in that case, the code owners aren't necessarily the same as the code contributors, so you do need some branching strategies. Every other time, it's applicable. But the second camp is mainly an aversion to change, just in general. This has always worked for us, so why change now? This should never be a software engineer's mindset. Our strength is the ability to learn new things and adapt quickly to change. Being stuck in your way as a software engineer is a fantastic way to become irrelevant. So we can cross that off too. Now, the last category of excuse is that it's difficult. And I think this is an interesting one. So let's talk about it. This year's State of DevOps report has made some changes to their target demographics. So previously, they focused a bit more on senior engineers. They had 40% of respondents having more than 16 years of experience. This year, they wanted to get feedback from more juniors, so that number dropped down to 13%. And the results showed that the less experienced developers showed negative results with TBD across the board, with a decrease in perceived overall performance, an increase in unplanned work, error proneness, and change failure rate. That's opposed to senior developers who showed the exact opposite results. So now this makes it seem like difficulty is a very, very valid reason for not adopting TBD. But the question is TBD itself difficult or a poor tool for inexperienced developers? I don't believe so. We had a junior engineer join my team earlier this year. Zappy was his first software job. Now, he's not committing 5 times a day yet, but he's been vocally positive about shorter-lived branches and testing in production. I myself have less than 5 years of experience in the software engineering world, and TBD is one of the loves of my life, closely behind my dog and closely ahead of my girlfriend. So years of experience can't be a real determiner for the success of TBD. And maybe that means that we're looking at it slightly wrong. Shia LaBeouf will try to tell you otherwise, but you can't just do trunk-based development. A trunk can't grow without roots. Roots to stabilize the tree, roots to feed it, and roots to keep it healthy. And these roots are software engineering best practices. I believe there's 4 of them which contribute primarily to the growth of this tree. The first root is design. When I first joined Zappy, and for about 3 years or so while I was there was never really a focus on designing your code. And documenting that design and getting feedback on it. Looking back, it's a bit shocking to me now. And it meant that the first time your teammates ever hear about your solution, your proposal, is when I'd spent weeks building the thing, and now I have a PR with 2,000 lines of code. And then someone comes along and they say, hey, there's actually a way better way of doing this, but at that point, you've sunk so much time into it that it's unfeasible to start from scratch. You've got deadlines, you've got PMs breathing down your neck. So the code goes in with the promise to clean it up later. And I imagine almost everyone has had a similar experience. And I also imagine almost everyone here has not cleaned it up every time it happens. So my team has been doing some very ad hoc design for about a year or so, but it's only within the last 6 months at Zappy that we've tried to formalize the design phase of software development by introducing RFCs. So RFC stands for Request for Comment, and it's just a design doc with any level of detail. But the reason for calling it an RFC is to emphasize the collaborative nature of design. Just like comments on pull requests, we want feedback on the design so that we can iterate quickly before we even start coding. And we found that we can save weeks of work by catching flaws after only a couple of days. The best RFCs come from being wrong. Now, I mentioned briefly that the amount of detail in an RFC can and should be flexible. So it becomes a little tricky to figure out when to actually write one. As much as we want design to happen, we don't want to write an essay for a one-line bug fix. So I try and use 3 indicators to figure out whether I should write a design doc. The first is if I'm at all unsure about some decision that needs to be made. The second, if I've got a number of different approaches in mind, but I can't really figure out which is potentially the best one. And then the last is if a solution or a problem is too complex to easily explain in a couple of paragraphs, then I'll write up a nice design doc and get some feedback. Now, design should be a priority regardless of trunk-based development, but TBD cannot happen without design. Because you want to commit small and fast, you kind of need to have an outline of what the stepping stones look like for a story, and that's only possible with design. This chart shows the number of deployments versus the number of RFCs for most of the teams at Zappy over the past year or so, normalized by team size. I will let you guess which data point is my team. The data is a little bit rough. Some teams were excluded because they only got formed halfway through the year. Some teams may not have uploaded all of their design documents to our database, but there does seem to be a correlation of sorts between the amount of time spent designing and the number of deploys per developer. Now, I'm not saying there's causation here. Just because you design a doc doesn't mean you're going to ship more, but it does mean that, or it does imply at least, that trunk-based development gets enabled by design. Next up, we've got test-driven development. You do need to be confident that your code going in is not going to break anything when you deploy it. And if you're deploying 10 times a day, then manual QA is not feasible. So you need a robust suite of specs to be confident that you won't ship breaking changes. And I'm talking about real test-driven development, not just unit testing. The strict definition is write your spec first, make it fail, write your code, make it pass, refactor, rinse and repeat. I will call on G. Hill again and say that we should focus on the benefits rather than the semantics. It's okay if once in a while you write your code first, then your spec. It's not the end of the world. But I believe the most valuable part of TDD is that the spec should guide the design. And there's a very strong correlation between code that's easy to test and that's easy to refactor. And both of those signal good tactical design and solid principles. In a case study involving some big development teams, teams reported a 15 to 35% increase or decrease in initial velocity when using TDD. And I think that can be explained by the learning curve. 40 to 50% of engineers found that adoption of TDD was quite difficult, potentially due to a lack of upfront design. But the engineers found that in the long term, their velocity increased, partly because the stability also increased. In fact, density of defects dropped by between 50 and 90% when TDD practices were followed. And then engineers found that their code quality was just better and their designs were simpler. So how do we get people to do TDD? I think the best way is pairing. Have your more experienced engineers pair with the juniors and show them how TDD works. Something I like to try do when pairing with a junior is to lead first, drive first, and just write the specs. So I'll just sit, write the specs, go through what they're supposed to do with them, and then I'll hand over the steering wheel to them, and they can write the code. And that way they learn the value of TDD while also doing the fun part of the coding. What are tests without some way to run them? The answer is the next route, a great CI/CD pipeline. Zappy's got an incredible SRE team, so I've never really worked in a world without good CI and CD. We have any push to any branch, runs your test suite, runs Jenkins build, tests for visual regressions on the front end. And deploying to prod is a simple one-liner in a shell. We can even deploy from Slack, but I'm pretty sure I'm the only one who's ever used that. So a great continuous integration pipeline allows us to be more certain that things won't break and alerts us at every stage of the process. And the best part is CI pipelines are incredibly easy to set up these days. Even for personal projects, you can build and run tests with a very simple GitHub Actions workflow. And we're at the point now where there's really no excuse to not have at least some form of automated CI. Continuous deployment, on the other hand, is a little bit trickier. There are some easy available options out there. GitHub Actions, again, can deploy applications straight to AWS. But as soon as your web app and your infrastructure becomes complex enough, then you have edge cases and strange things starting to appear. But adoption of continuous deployment does require real upfront investment, but it's one of the most critical components, not just for trunk-based development, but for efficient software engineering just in general. And then finally, we've got feature flags, or feature toggles, as they're also known. These allow you to switch pieces of functionality on and off for certain users. The most simple feature flag is just an if statement, which maybe enables something locally. But you can also use services like Launch Darkly, which is what we use, and they provide more advanced targeting functionality. Feature flags are what allow us to test in prod, my favorite thing, and it makes QA faster and more reliable, and avoids straggling PRs being blocked because QA hasn't had time to get to the code. But they're for more than just QA. Feature flags can be used to safely expose early-stage features to alpha or beta users. They can be used for A/B feature testing. And with the really advanced tools, you can even have controlled incremental rollouts to your customer base. But my favorite application sorry, I was supposed to put up a flag there. My favorite application of feature flags is quite a selfish one. And that's that they allow the devs to ignore the bureaucratic crap that surrounds releasing a new feature. This here is a chart on our platform. It shows the behavior change score in a survey for 4 different ads. Pretty easy stuff. The behavior change question asks how likely a respondent is to, purchase the product in the ad or something along those lines. And in this case, it was asked on a scale from 0 to 10. And again, in this case, we want to display the result of that score as a mean. So we just mean across all the respondents and get the number. And that calculation type is displayed at the top next to the behavior change label. Because we can switch between top box, mean, whatever you want. We thought it's a good idea to have it there. But based on some feedback we got, customers can quite easily see that it's a mean. So they just said it was noise, it made it messy. We decided to remove that little mean. So our new chart looked like this. Being a very small change, it was done within like a few hours, and it was shipped to production, and then things just got messy. We had sales and customer-facing reps shouting at us that we hadn't notified them properly, so now their sales pitches and their demos were all out of date. Our product manager asked us to quickly revert so that we could appease the business, but we still wanted the change to go in. To get approval for this change, it took 2 months to put all the documentation together and communicate to everyone that needed to know this. That little change there, From that to that took 2 months to get approval. It was a one-liner, I think. 2 years ago, that PR would have been lying around for those 2 months in PR hell. But now we have feature flag. So we just added a flag to the code, shipped it, and gave control of the toggle to the PM. Presumably, at some point, he got all the communication out there and turned it on, but we didn't have to be involved. So yeah, getting people to use feature flags heavily, like everything else that enables TBD, is not an easy task. There's a financial cost when integrating with a flagging service, and devs need to be convinced to change their behavior. It does take time, but eventually you get there. At Zappy, we have 69 engineers at the moment and 88 active feature flags. So I think that is quite a success. So all the data shows that adoption of these best practices, while very beneficial, is not always easy. During the early stages, velocity and developer happiness tend to decrease. Engineering mindsets and organizational process, they all need to change, and an upfront investment in technologies and training is vital to the success. And even knowing what the roots are and understanding their value is not quite enough to bring about changes and achieve adoption. And that's where you guys come in. Adoption doesn't happen without people with the drive to push for change or without people willing to embrace it. And it's not just the EMs and the tech leads of the world who have that power. Anyone with the right mindset and the data to back themselves should be able to convince others. Now, it doesn't happen overnight. You can't force it. So the best bet is to lead by example. Start writing design docs for any ticket that you pick up. Share them with your team. When pairing, write your specs first. Use simple feature flags, even if they're as basic as if rails.env.development. But there's even more to an effective culture, to an effective team than just software best practices. We need to nurture our people and our culture. It's been repeatedly shown that teams and organizations with a generative culture and flexible work arrangements outperform those with bureaucratic or pathological cultures. Stable teams with devs who stick around are more likely to be the norm in high-performing organizations. But above all of this, we need trust, which is the most vital nutrient needed to grow the tree. So back to the original question, why is it difficult to adopt trunk-based development? I think the answer is because trunk-based development itself is not a goal, it's a metric. TBD is an indicator of good software engineering practices and team health, so your focus should be on the roots and the soil, because without those, the tree won't grow. So go forth and crush it, and I hope you learned something. Thank you. Cool. I guess we have 2 minutes, so if anyone has any questions, then shoot. So question is, how long does our CI take to run? We've got a number of different apps. Some of them take 2 minutes. A couple of them take longer, I think up to 20 minutes is our longest one, something along those lines. Yep. So the question is, how do you handle like dependent PRs? I think on one hand, if a lot of different files are dependent on each other, that's an indicator of high coupling, and maybe you can have a look at your design. But the other thing I like to do, or I like to think about, is that everything can go in separately until you have a kind of tie it all together PR, and that's when you bring in, the dependencies. That one obviously comes last, but yeah, I do like to think of the tie it together PR coming at the end. Yeah. So the question is around how we deal with unused code. We do have tools for it. I can't remember what the tool is called, but you can like track, you can monitor which code is actually touched with Rails. There's some gem for it. But a lot of the time, it's just on the developer to kind of remember and clean them after themselves. The question is around automating rules for I guess, big commits. The answer is no, we haven't automated things. Just because it's like, it's a judgment call. at the end of the day, putting too rigorous rules in place, I think, leads to more drama than it does anything else. So I'd rather just make a judgment. All right. I think that's it, right? Thank you.